Hello, my name is Maartens Lourens. I'm a DevOps consultant with OpenCredo. Most of you know me. And I decided to call this talk Beyond DevOps, Machine Learning and AI. Now, can I see a quick show of hands? Who of you have heard of AlphaGo? Quite a lot of you. That's great, thanks. So AlphaGo, as you probably know, in March 2016 challenged Lee Sedol, who is a world-class former world champion Go player, in a champion set of 5 matches. And this made world headlines because 4 out of these 5 matches were won by the AI and not by Lee Sedol. And this is really significant because up to that point it was really thought that Go is so much more complex than chess that it will still take a few years before computers and artificial intelligence can actually catch up with what happened with chess in the past. And in other words, beat really top human players. Of course, inevitably, when this happened, some people also thought of Skynet, the not-so-friendly AI in Terminator. But there were also detractors, people who remembered what happened in 1997 when Garry Kasparov played against Deep Blue. So at that time, Deep Blue beat Garry Kasparov, but after that, not really a lot of high-profile things happened in the world of AI. So people said, well, you know, we've seen it before, what can happen? However, there is one big difference between 1997 and what we have today, and that difference is machine learning. And AlphaGo really is just the tip of the iceberg. So the aim of this talk is to get you just a little bit excited about machine learning, and secondly, to point out some of the projects that I think are worth looking at. So let's begin with Gartner. Gartner is our industry's analyst or top analyst body, and every year they try to make some predictions about what is going to be influential in the future. They have the famous Magic Quadrant, and towards the end of last year they put out their top 10 strategic tech trends for 2016. And 4 out of 10 of these were related to big data. And that's quite a lot when you think about it, 40%. So let's take a quick look at those. The first one of these, the device mesh. What is a device mesh? Well, in a phrase, we can think of it as the Internet of Things. You have your local network. In your local network, you might have a laptop, you might have a mobile phone, your fitness tracker, and various other intelligent devices that talk to each other. In the device mesh, you also have dumb devices. It could be your fridge, it could be your car, it could be any object that gathers data and then talk in the network to each other or up to the cloud. The next one is the ambient user experience. The ambient user experience tries to create consistency across the various device meshes in time and space. So these two work closely together. Then thirdly, there's the information of everything. So the previous two, they were generating a lot of data already. But the information of everything is an idea that you have to interpret this data now, create a semantic layer of meaning. And then lastly, as you've probably guessed by now, we have advanced machine learning. Now, all 4 of these are actually really close together, in my mind at least. They all relate to data. And the fact that Gartner has decided to split out, especially the first 3, to me is a sign that they really want us to sit up and take notice. They're not just putting them all under the same umbrella anymore. So with advanced machine learning, we have seen some really good advances recently. And I think of this as a layer on top of these other data areas. Google's Eric Schmidt, he's making the prediction that within 5 years, every major IPO in the tech industry is going to be related to machine learning in some way. That's a big prediction. Just 5 years. NVIDIA's Jensen Huang, he's the CEO, he says that in the last 2 years, they saw a 35 times growth. That's a big figure, 35 times growth. So machine learning really is something that's starting to bloom. But what is machine learning? Well, if you start looking on the internet or anywhere else about what machine learning is today, you'll see it's a vast field. There are many different categories here. The way I like to think about it is that you have a lot of data, And then you have some algorithms, various algorithms, some better than others. And then you chuck all this data at these algorithms. And what you're automating is the analytical predictive data model that comes out of it. And that gives you then a lot of training data. And from this training data, you can find many different kinds of applications. Deep learning is a kind of buzzword that has been making the rounds. You've seen Google's Deep Dreams, you've seen all other kinds of the word deep on various other kinds of gimmicks. It really is just a buzzword, but what it refers to is neural networks or machine learning that have hidden or deep layers. And two of the most popular and most influential currently are the convolutional neural networks, CNNs, and recurrent neural networks, or RNNs. Although they are very popular and influential right now, this wasn't always the case. Back in the 80s, something similar happened. There was a lot of enthusiasm for artificial intelligence. Back in the day, they used to call it artificial intelligence and not machine learning so much. And the area of speech recognition in particular was seeing a growth spurt. And this was largely due to things like backpropagation creating breakthroughs in this area. Concurrently, a development in expert systems meant that a lot of new expert systems were being bought up by companies, and there was a lot of enthusiasm for, on the one hand, these neural networks, and on the other hand, these expert systems. But then, as these two developments started to move forward, both of them hit some stumbling blocks. Expert systems, first of all, didn't really deliver on the early promises and became too expensive to be maintained. And at the same time, the neural networks started to hit some fundamental theoretical problems. This is a big problem for researchers. Some of these problems are the famous ramification problem, the qualification problem, the frame problem, and others. As a result, the whole industry started to lose faith in artificial intelligence and in neural networks in particular. And so they started to withdraw their funding from these areas. And this is what is known as one of the famous AI winters. However, there were some heroes. These three guys in particular, Jan LeCun, Joshua Bengio, and Jeff Hinton, remember their names because they actually kept faith with neural networks throughout this AI winter in the 90s and early 2000s. And they are largely responsible for the resurgence of interest in this field. Another guy whose name you might want to look up is Andrew Ng. He's part of a younger generation, but he's also been making waves in this area. Some of the interesting technical projects that I really want to draw your attention to are these three: Theno, Torch, and TensorFlow. I put them in the same bracket here because they're actually largely similar. They all try to do things in this broad area of deep learning, but they have slightly different timelines. Theno, as you can see there, is from Joshua Bengio's lab in Montreal. Joshua Bengio was on the previous slide, and uses a Python interface for its framework, which is similar to what Google offers with TensorFlow. TensorFlow was recently open sourced as well, and also uses Python as its language of interface. That is interesting from the point of view that Python already provides many libraries for scientific computing. There is NumPy, SciPy, and numerous others. Then there is Torch. A few years ago, 2 or 3 years ago, Facebook open sourced this. They use LuaJIT. And one of the good points about Torch is that it's very good for debugging. So researchers who are trying to develop new algorithms like using Torch for that reason. LuaJIT itself is also quite expressive. Some people prefer Python nonetheless. At OpenCredo, we are usually very good at keeping abreast with new trends. We like to try out cutting-edge technologies. And in recent years, DevOps and microservices have seen a rich vein of form. However, I can see that there's going to be a data revolution. And this is not just me saying it. The evidence is everywhere. And I think machine learning is going to be spearheading this movement. And I definitely think because of this, our company should start looking more and more into this area. So please keep in touch. Go to the Slack channel, #machine-learning, or catch me on Twitter. For those who are going to get the slides, there are also some links right at the end there.